Hey everyone, today we're going to be looking at this thing, which is a Cricut heat press. I think it's called an Easypress. Has a hot plate on the bottom and it's just used for heating up things. An artsy device, stick-on transfers, I'm not sure. Anyhow, we have it plugged in, follow the lead, we can turn it on. And it turns on and it shows current room temperature about 20 degrees. Now this one does not get hot. Apparently when this button here is orange, which it is, it should be heating, but it's not heating. So now I'm just going to blow some hot air at the plate and we'll see if the temperature goes up. Okay, we've seen it's gone up to 35 degrees, it was 20 before, so it is able to register temperature, but it's not switching on the element. So after a period of time, about 2 or 3 minutes, we get that error 3, and it turns off. So obviously that error relates to it is unable to sense an appropriate change in temperature over the expected time frame. Right, so looking at how to get this thing apart, on the underside we have some screw holes all the way around. Now they've got these little rubber bungs in that you have to pick out, and then you just undo the screws and they all come out. And you would think that would probably do it, but this is firmly attached. This white section will not separate from the base, and I cannot for the life of me find out where the clips are to make this thing let go. Like you can get your spudger in there and you can kind of separate. Yeah, you can kind of sort of pop that out from the side there, but I mean, you can do that all the way around, but it really feels like something is probably holding it from the top side. So now I'm wondering if maybe there's screws down in here, and then this pink section is inserted last to cover those. And I've been trying to pick this off, and man, what a mission! Like it's kind of unclips. Like you can there's a gap forming there, you can sort of see clips around there, but yeah, I haven't really been able to let have that let go. And then I'm wondering if maybe the handle, so this section under the handle might have to come off first, because there's a groove here, separation here, so we probably can't get this base section out until we've got the handle section off. And again, you know, you can pry along here and whatnot, but it is really firmly attached. However they've put the clips, it was definitely designed not to come apart. Good grief, that was a mission! Alright, figured it out, but here's how it happens. You get all the screws out. Now I had to, I thought I could pop these covers off, because as you can see, there is clips around here, and I thought I could get the plastic off, but that doesn't come off. The pink plastic stays there. So what happens is, well, what I had to do, slip a screwdriver right up there at the top and lever on it, pull out, which is kind of having the effect of pushing the grey section down. And while I'm levering that up, unclip, get a spudger all around the edge here and just unclip as you go. And then, you know, all around this edge here, around the inside, along this edge here, and you've got to clip it, unclip it as you go, and then unclip along the other side, and eventually let's go. Now it does tend to want to go straight up, but it was yeah, man, who would have thought? I found the patent diagram. So US patent number 202.100.71349A1, and it's got some drawings of, you know, some I wouldn't say CAD drawings, but yeah, some drawings of the lid off, but it didn't really help me. I was just prying away, and then all of a sudden had a moment, and there we go. So we're in. Maybe we can be the first one in the world to fix this, because I can't find anyone online who's actually resolved this. Most people are getting replacements from Cricut, but some people aren't, so maybe this will be helpful for them. So now I guess that's just going to pop up, and we've got to watch our power cable there. It's fixed, so we just need to see what's going on there. And oh no, there we go. It's going to slide into the cover. This is just a sort of a silicon bung. It's sliding over that, so we can slide the cover down over the cable. There we go. That should give us some good access. Now, oh, I see some wires attached. Okay, the top panel's coming with. Control panel is not. Okay, we turn around here. There we go. We can see that, and we want to unplug those. Alright. So that 2-wire, that plug there, given that's 2 wires and kind of has a feel about being a temperature sensor, does go down into the hot plate, that they always seem to have the same sort of wire. It feels like that. And 3 wires is going to be power and heater control, I would say. So it'll be yeah, 3 wires. So it'll be power for the control board and a on-off signal to the heater regulator. So wonder if I can I take the power cord out completely? Probably not. Okay, I might unscrew the board, the control board, so we can work with it. So what have we got going on here? Looks like, is that our power supply on the top? I think so. We've got our 3 wires running down from here. So it's a small switching supply to run the controller, and what I would say is probably, what's that, a triac? Maybe? It's going to be a 240 volt hot plate element. What's the number on that? Oh, I just made a mess of it. Ah, no! Horrible white thermal compound. Okay. T1635 or CK. What is that? ST. It's an ST brand. Yes, a 600 volt, 16 amp triac. I'm guessing it's either that's failed or the heating element itself. So we will check the element first. I can't really get access to the wiring for that easily, so we're going to have to remove the handle section. We've got screws on the side, there, and on the other side, and probably the one in the middle, and it's the same on the other side. We'll see where that gets us. Now, remembering that you have unplugged this, of course, you don't want to be working on it while it's plugged in. This entire metal bracket across here is live, according to that little sticker with the lightning bolt logo in it. That means that this is live. This will be mains voltage. So in my country, 230. Yeah, in your country it might be 110. You still don't want to put your finger on it. And the reason it is live is because the triac heatsink is directly bolted to it. So yeah, We're going to get that out. There we go. A long one in the middle. Plastic screw. I nearly destroyed this trying to get it open. That was rather frustrating. Good design, but didn't help anyone. Yeah. Can we lift? Okay. The only way that's coming off, obviously yeah, we'll have to unbolt the triac as well. I'm hoping it's threaded, because if there's a nut on the other side, I'm not sure how they would have got that together. Let's try and do it. Oh, it seems to be a threaded or a captive nut at least. Stick that on there and get white goop everywhere. I have to lift that up. We don't want to go bending it too much and snap the legs off, just enough to get the bracket off. There we go. There's nothing obviously burnt down there, and if there was anything burnt we'd be able to smell it. But we've got our mains coming in. Where's our mains coming in? They're a shared neutral to the element and a switched phase. So we've got our neutral coming in here, which is teed off further down, it looks like, goes to the element, and up here to power our control board. And then we've got our phase in and phase out from the triac. So just need to, they've got very basic switching supply for the output. This could be the problem if it doesn't turn on at all. Be something like this. Or, I mean, there could even be a thermal cutout, or quite likely a thermal cutout on the phase line in as well, which will stop it. Now, how is that held on? Still, okay, it's screwed from underneath, so this pink section is screwed from underneath, which means we'd have to, there we go, we'd have to undo these screws. There's one here, there's one under there, and a few more around here. They must hold the element on. We'd have to undo them, clear the element, so we can come up from underneath and release this. So let's see if we can poke a multimeter lead under there and find if we have, well, we know that neutral's common, so we can just measure that on the mains cable. Plug, I got phase on the left, neutral on the right. So I'm going to stick one probe on neutral, and then I'm gonna just tuck in here where the wire meets the PCB and see what we've got for resistance. And that's shocking. That says 36 million ohms, which is not going to heat up anything. What do we got on the phase in? Oh yeah, okay. Yeah, so yeah, hopefully that's all it is some thermal protection and not the element that's blowing. That would be a shame. I'm pretty much sure I'll never buy one. It'll be a custom design. So now we have to do what I didn't want to do and undo all of these screws and get this section loose so we can see what's going on underneath. Okay, I've taken these screws here out and the ones that are just under the edge of the pink there, all around, and it looks like it's separating, so that's good. So what is holding it back? There'll be some amount of cable flex that is stopping it. It won't be releasing, imagine. Can we see through there? No. Oh, Oh, actually, I got some insulation material. Okay, so there's wire. Oh, it's an earth wire coming down here. Oh, crap. Okay, I see what they've done. I've made it one more assembly step that's made it hard to service. So as can be seen here, there's our earth wire. Earth wire runs down the hole down to the base plate, the heating plate, and it's been crimped together with the mains in cable, and that's what they've done on the other side here as well. So we cannot separate it. We have to undo those crimp connections so the cable can pass through the frame and allow access down there. That seems to be the way. I wonder if we can actually get some slack on this somehow. Maybe if we undo the mains cable, it might give us enough slack to separate things enough. Just undo that locking little piece across here to give it some anti-pull resistance. Yes, I know, I could have left that one screw in and just swung it out the way. Now, how much slack have we got? There we go. So we can let that earth wire down and pull that up and get that one up as well, maybe. Yep, just untuck it out from the side there. That allows the cables to feed down the hole as we lift it. Oh, we've got one more over there, the neutral. See if we can pop that out. A little bit tricky the way it was tucked in, but I was able to pull that out. There's enough give in the wires. So now, hopefully, as we lift this, we should have some slack to feed those cables down and let it hang and separate enough for us to see what's going on under here. And what I can see is there's an insulated material there and 4 more screws, and that goes down to a temp sensor. Okay, I might just let's probe the heater element up here. I may have misread that circuit, so I was probing on, oh no, I was probing on the right one. Yeah, okay. How was I? Thus switching neutral. Wait a sec. That's not right. What do we got there? Neutral comes in, phase goes to there and out to there. Oh yeah. Oh, okay. Neutral must come back. I misread how they've hooked it up. Let's take a probe at these crimp connectors here on the heating element and see what's going on. Maybe I was right. That's still 32 million ohms. Yeah, okay. So they've got phase coming in, which is shared down to the element. So they're switching neutral. I thought they'd switch phase, but they're switching the neutral side through the triac. So now we'll take these screws off. Now these cables are going to pull up through the underside, so we will come up through here and let them pull back down through the other hole and see what we got. And oh dear, and here what we can see is we've got this side, there's a copy over here, we've got neutral, phase neutral. Okay, so here's what we can see is we've got the wires coming down on the left through this protective tubing, and under these clamps we have a thermal fuse and then the connection to the element itself. So I'm going to measure on those pins there. We'll check the element. I'm thinking it's probably a thermal fuse. What have I got to prop that open with? So across our element we actually have 47 ohms, which is much better. That would definitely get warm. Now let's check between each one of these and the wire line in on the other side of that thermal fuse. Where do they join that on? Is it here? No. I'll go back up the top to that initial wire joiner that we were probing before, and we've got, okay, so that must be our other side. Nothing both sides there, nothing there, and nothing there. Well, what are the odds both of our thermal fuses have quit? So our far one is okay. If I follow the brown wire back down in there, no, our brown one's gone. So the thermal fuse closest to us is the bad one. So we'll take the screw off here, and it is a, what have we got here? Little clip. Opened up like that to push it off. And we'll find that the wires are actually crimped on as well. So however we end up, we're going to have to crimp the wires together really solidly, because this is a very high powered connection, and we don't want the connection itself getting hot. So now I'm going to check the triac, because these thermal fuses are rated at a temperature quite a bit higher than what you can set the control to, so it should never blow them under normal operation. But if this thing shorts and it's passing mains through to the element uncontrolled, then it'll get super hot, and that sounds like what may have happened. Because it was sitting on something and it got so hot that it burnt the sort of special paper it was sitting on, I believe. So you know, that sort of suggests that, yeah, it got too hot. If we look at the back of this package, left to right, we've got the gate and then AC1 and AC2. So if we go across the gate and one of the AC pins, so I'm seeing 0.045 on the diode mode. Let's just do a resistance out of curiosity. It could be, there's 38 ohms gate to AC, so I may have to take that out and test it out of circuit just to be sure, because that 38 ohms, if you've got AC on one side, it could trigger the gate to latch on. I mean, especially when it's a 1 volt gate. Apparently, so it doesn't take much to turn it on. If we go from the right pin, or the two AC pins, I'm getting no connection through there. But like I said, if it's an internal short which is turning the gate on, then we're going to get current flow regardless. But let's take it off the board and test it out of circuit. So I've got the devices out. Here we go. And if we go across the gate and AC pin again, yeah, I think it's shorted internally, which was causing that to switch on uncontrolled. And looking ahead, I found on RS Components they're about $5 each in a pack of 5, I think it was. So yeah, what are you going to do? These things are probably about 300 odd New Zealand to buy, so it'd be worth fixing. It's been some months, and it took forever to get all the parts together that I needed for it, but finally got them in. So got a bag of little crimps, little joiner crimps that we need, and they're designed to just wrap around a wire. Yeah. A packet of triacs and a packet of thermal fuses. And what held it up was obtaining a crimping tool that would actually work with that style of joiner. Even then it's not the greatest, but it gets it done. Only it's been so long I forgot that I was halfway into a video and I've already done that half the repair. Unfortunately, I've put the new thermal fuse in. I ended up, I grab one. So there we go, thermal fuse with the legs out. And what I ended up doing was, leaving part of the leg of the old one attached to the crimp that it was already in with the wire, and then I just fed the leg of the new one into with the leg of the old one into the little crimp there, and wrapped it around nice and tightly. Alright, I will give you a demonstration as to how this worked, because it would be useful, wouldn't it? Here is the crimp connector up close, and what I ended up doing, if you imagine one of these, oh, this is going to be fun, isn't it? Okay, I had the leg of the original one, say the one on the left, and that was still attached to the wire coming in, and then the new thermal fuse, if that's the leg of that one, and just lay them together in there, and crimped it down. Now these are just a little bit spread apart too far to fit in the section I'm using, which is the 22 to 26. So what I was doing, just squash it closed a little bit, just to get it started, and you can pop it in here and slide it up into place, and then you would have your component legs, and that would be one on each side like that, and you give it a squeeze, she should wrap around, and they're a lot fatter than these, but yeah, you get the idea. So a couple of these that are bigger. Here's the original ones, quite a bit fatter, as you can see, because the example I'm using is just snipped off a resistor. So look at that, they're out at least twice as big. So you give it a squeeze and they curl up and clamp around the wires, and that's a stronger than soldering, well, sorry, more reliable than soldering, as solder melts at close to the temperature that we are using, and over time it will all those sort of heat cycles of that level, it will eventually let go, so we cannot solder. But it's all back together almost, just in the process of putting this heat sink on. The new FET is soldered into place. I had to screw the FET to the heatsink, bend the legs to suit getting it into the PCB, and then fitting this in place onto the PCB, and then just getting a solder iron down in the gap and just sort of squeezing it down in there, and soldering a couple of legs on to hold it in place, then disassembling it, taking the heatsink off again, and feeding all the wiring down the sides, making sure that goes back where it's supposed to. But that way it gets the triac. Did I say FET? Triac. That way it gets the triac in the right position, so when it's all back together, the screw lines up with a hole in the tag, and there's no issues. Now, before we clip it all back together, I feel I should test it, given how difficult it was to take apart. Let's cycle it and make sure that it's okay. We'll get it up to full temperature, I guess, and make sure the other thermal fuse wasn't damaged by the excessive heat to the point where it's going to fail prematurely. You know, it may not allow it to go as high as it should, but yeah, we'll give it a shot and see what happens. So our current set temperature is upside down, but it's 100 degrees Celsius. So let's set that. Okay, it's actually on at the moment, so it's coming up 25. It's gonna wind up to 100, and you can see on the thermal probe we're at 44 and climbing. I guess if it samples that slowly, it might overshoot. We're already at 80 degrees, and it said 75, 80. It's about 5 behind, isn't it? 90. Oh, no, it's catching up. So it's hit its set point. Maybe my temperature probe isn't perfect, but it's just jammed under one corner against the silicon in the support tray. Close enough. Let's set it to and how hot it gets up to. Does it have a fast mode, or do you just have to hold it down? 205. Well, there you go. If 205 is the maximum temperature, these 250 degree rated fuses should survive. 180 according to the numbers. They seem to coincide all right. I wonder if it's full mains through there, or if they regulate it. There we go. We've hit maximum temperature. So just to prove that the triac is functional still and hasn't shorted due to some other fault, you can see the probe on the left is not climbing anymore, which if it was shorted should be going as hot as possible. So it's easily maintaining that temperature. Might let it sit there for a few minutes and make sure it stays good. The probe on the left has reached 200. It seems to be regulating the temperature pretty well. I'd like to drop it on something to absorb some of the heat, but see how quickly it responds to that. But not while the lid's off it. You don't want to touch the metal along here that the triac's bolted to. That metal is live. That will hurt. Well, that looks successful. Let's put it all back together. And there we have it. One Cricut heat press repaired. There's the hot plate on the bottom. Non-stick coating by the look of it. You could iron your clothes with that almost. Yeah. So hopefully that helps you figure out why your one doesn't work. I believe it's a bit of a common problem with these, although I don't know if anyone's really published the cause of it, but I've seen a lot of them with the same fault this had, and a lot of shrugging of shoulders as to why it's happening. So yeah, there we go. Thanks for watching, and we'll catch you all next time.